Okay, so from the videos that I just showed you, this graph is going to demonstrate those two variables. What are the two variables that I just introduced to you? Pressure and temperature. Okay? So, it's not only the temperature that makes things change, it's also the air pressure. Alright, this is what you need to memorize. This section of these graphs is always going to be the solid section. So whenever you see a graph that looks like it has the weird Y in it, that's what we call a phase change diagram. And it's going to demonstrate the three different phases. That part is always going to be the solid part. This part is always going to be the liquid part. Liquid. And this is always going to be the gas part. Alright? And that's the only thing that you need to memorize. Because when you see one of these diagrams, it's not going to say solid, liquid, and gas, but it's our job to memorize the solid, liquid, gas. It goes like in a little arch. Solid, liquid, gas. Alright? So, phase changes, I just showed you that you can get a liquid to turn into a what? A gas. By manipulating the air, what? Pressure. Okay? So in a certain situation, if you start at a pressure all the way up here at 1.5 and you drop that pressure all the way down to 50, is it going to change states of matter? Yes. Okay. From yesterday, what's the vocabulary word of a liquid that turns into a gas? Vaporization. Vaporizing. Okay, so that beaker vaporized. How did that beaker vaporized? Because we decreased the what? Which one? Hold on, look at the y-axis. Look at the y-axis. Do you see how I'm traveling straight down vertical? Okay, the vertical one is pressure. So how did I get it to go from a liquid to a gas? I decreased the air what? Pressure. Perfect. Remember when I said use your imagination? Pretend like there's no more air pressure and those molecules can turn into a gas. Awesome. Okay, this graph also shows you what you already knew. You could get a liquid to turn into a gas this way too. What's another way that you can force vaporization to occur? Instead of pressure, you can manipulate the what? Temperature. Does it have to get hotter or does it have to get colder?
Hotter.
Yeah. Okay. Another way to get something to vaporize is to increase the temperature. Do you agree? Okay. Does everybody understand what I just did? I showed you two ways to get vaporization to occur. What was the first way that you could make it happen? Decrease pressure. What's another way that you could make it happen? Increase pressure. Okay, this goes for everything. I'm going to change colors. We're going to go to green. Sure. Okay, it goes for anything. Pick any two states of matter. Ready, go.
Gas.
And solid. Okay, he says gas and solid. Uh-oh, what's the term? This is a hard one. What's it called when a gas instantly turns into a solid? Anybody remember?
Freezing.
Gas.
Oh, gas.
It was a weird one.
Sublimation.
The opposite of sublimation. Deposition. Okay? Alright, those vocab words are something you're going to have to practice. Alright, deposition. Yeah, you're right. So if a test question says, oh, what's one way that I can make deposition occur? The word deposition means to go from the gas into a solid. Look at the arrow. What's one way to get deposition to occur? Increase the pressure. You're right. Increase the pressure. Okay, that's what I did with the finger. Remember the finger that turned a gas into a solid? Okay, it's because you were applying more pressure. You were increasing the pressure. All right, what's another way that you could also get deposition to occur? Making it really, really cold. Okay, so this graph shows you that if you get really, really cold, like I told you in Michigan, you can get that air to instantly freeze. Okay, so there's two ways to make deposition occur. Put a whole bunch of pressure on it, or make it really, really cold. Do I know them? I don't have any relatives in Michigan. Does anybody else in here does? Because it's really, really cold right now and the air is instantly freezing onto the cars. I know. He's like, wait, what class are we in? That's awesome. That's awesome. Trapped in the house all day because he's so afraid to open the door because maybe his hand will stick to the doorknob. Yeah. She was there? Really? What? There you go. Snowboard off the roof. That's awesome. Okay. Yes, snow is awesome. We can get snow to change into all these different phases. Do we need to do one more example? Oh, good. Let's do one more. Pick any two phases. Ready? Go.
Solid liquid.
Solid liquid. Solid liquid. All right. Liquid. Plasma. Plasma is the only thing we're not going to talk about because it only exists in the solar system, on the sun, and in the stars, because those temperatures are so extremely hot that even a gas molecule changes phases of matter. That's what plasma is. But it doesn't happen on Earth. No, those are plasma cells. It's a different name, but it's not the phase of matter called plasma. What? Oh, no, yeah, you have plasma cells in your body, and that's the name of the type of cell, but that's not plasma that exists on the sun. And a plasma TV, ooh, what is a plasma TV?
Because it is plasma, but it might be a plasma cells, I don't know.
Well, I think
they move, I know that.
would be a lot more expensive if we had to go all the way out
To the sun. I don't know how to get I don't know what a plasma is. All right, here we go. Like he said, liquid to a solid. First, let's think about the vocabulary word. Liquid to solid. I'm going to call on someone. How about
Condensation.
Lucas? Liquid to solid. What does it mean to go from a liquid to a solid? That's freezing. You're right. All right, so this phase change right here is freezing. I need two ways of how you could make freezing occur. What could you do?
Decrease the temperature.
Decrease the temperature. Or,
Increase the pressure.
is it increase or decrease? Hold on. Think about a liquid into a solid. How do we get from the liquid into the solid? You have to increase the increase the pressure. Agreed? All right. You can either think about it because you can imagine it in your mind, or you can think about it because you follow an arrow on a map. Right here, go ahead and put a star right here in the middle of the Y. Thank you. Awesome. What did he just say? Triple point. Right there, where all three lines meet, is the point at which there is a liquid, a solid, and a vapor occurring at the same time. Okay, we call that the triple point. Let's practice with this one question. If I had a quantity of this substance at a pressure of 0.75, here's pressure 0.75 and a temperature of negative 100. Okay, think about negative 100 and 0.75. What phase are we starting in? Solid. Good. Okay, right here. We're starting in the solid. 0.75, negative 100, agreed. The question says, what phase change is going to happen if I push the temperature all the way to 600? It's going to turn into a gas. You're exactly right. From a solid, does it have to go through the liquid part first? Solid to a liquid to a gas. Okay, so what's it called when a solid goes to a liquid? Melting. What's it called when a liquid turns into a gas? All right, do you understand how to do the Y graph? Do you understand how to do the graph that looks like up, across, up, across, up, across? All right, if you can understand these two graphs that you can manipulate pressure and temperature by increasing or decreasing them, you can cause phase changes to happen. The other graph just shows temperature. Are you okay with that? All right, I'm done. I told you 10 minutes. I went 11. I apologize. It's because you guys got me distracted talking about weird plasma stuff. But I'm done. Homework number 2 is due quickly.